All right, let's just jump right in. When you think about empty space, what's the first thing that pops into your head? For most of us, it's probably a perfect vacuum, right? Absolute nothingness.
Yeah, exactly. The picture we have in our minds is a place that's just completely silent. No matter, no particles, and for sure no energy. Just a state of perfect, absolute stillness.
But here is where things get really weird. According to the strange and wonderful rules of quantum physics, that picture in our heads is completely wrong. That perfect, silent void, it literally can't exist.
So, if it's not truly empty, what in the world is going on in so-called empty space? Well, it all comes down to something called quantum jitters, the fundamental reason why, at the deepest level of reality, nothing can ever be perfectly still. And this all stems from one of the absolute bedrock rules of the quantum world, the Heisenberg uncertainty principle. All this really says is that it's fundamentally forbidden. I mean, it's literally impossible to know a particle's exact position and its exact momentum at the very same time. The more you pin down one, the fuzzier the other becomes. And this is where our everyday classical physics just completely collides with quantum reality. In the old school view, absolute rest was simple. An object's position and its momentum could both be perfectly zero. Easy. But quantum mechanics says, nope, can't do that. To be perfectly still, a field would need a precise position and a precise momentum of zero, which the uncertainty principle forbids. The result? Every field in the universe must always have a tiny, unavoidable oscillation, a constant jitter. And physicists have even nailed this down into a formula. Now, don't worry, we are not about to do a bunch of math. The only thing you need to notice here is that this equation, the one for the lowest possible energy state, is not zero. This is the mathematical proof, baked right into the laws of the universe, that you can never, ever fully drain a system of all its energy. So the crucial point, the main takeaway here is this. Even when a quantum field is chilled down to its lowest possible energy state, its absolute ground state, it must still contain some energy. It has to keep jittering. And that fundamental, irreducible energy that's left over, that is zero-point energy. Okay, I know. That's a pretty wild theory. But how do we know it's real and not just some mathematical oddity? Well, that's where we find the proof in the push, all thanks to the amazing Casimir effect. You see, this zero-point energy isn't just sitting there quietly. It actually expresses itself as something called vacuum fluctuations. The best way to picture this is to just throw out the idea of the vacuum being empty. Instead, think of it as a restless, churning sea of tiny, rapid oscillations happening everywhere, all the time, in all quantum fields. So, how in the world do you prove this invisible sea actually exists? With an incredibly clever experiment. First, you take two perfectly smooth, uncharged metal plates and you put them super, super close together inside a vacuum. Now, those vacuum fluctuations, that restless sea, it's happening everywhere, both outside the plates and in that tiny gap between them. But here's the kicker. The tiny gap between the plates actually restricts which fluctuation waves can fit inside. You end up with fewer possible fluctuations between the plates than in the wide open space outside. This creates an imbalance, a pressure difference, which results in a real, measurable force pushing the plates together. And get this is not just a thought experiment. The Casimir effect was predicted way back in 1948, and today it has been measured with incredible precision in labs all over the world. It is the smoking gun, the physical, undeniable proof that the energy of empty space is very, very real. Now, of course, the moment you hear the phrase limitless energy is everywhere, your mind naturally leaps to one really big question. And that brings us to our next section, the free energy myth, where we're going to need a serious cosmic reality check. So let's just ask it. If this energy is literally woven into the fabric of space-time itself, can we just tap into it? Can we build a device to harvest it and solve all our energy problems forever? The clear, unambiguous, and definitive answer from physics is no. And here's why. You have to remember, zero-point energy is the lowest possible energy state. It's the ground floor. You can only get useful work when energy moves from a higher state to a lower one, kind of like water flowing downhill to turn a turbine. But with zero-point energy, there is nowhere lower to fall. It is the absolute bottom. It's the background noise of the universe, not a fuel tank we can tap into.
But just because we can't use it for fuel doesn't mean it's not profoundly important. In fact, this energy is shaping our entire universe. So let's look at our final section, the universe's hidden engine, and see the incredible cosmic consequences of this nothingness.
It turns out, zero-point energy might be the hidden hand behind some of the biggest mysteries in the cosmos. For example, the Higgs field has a non-zero energy in the vacuum, and it's this very energy that gives fundamental particles their mass. How cool is that? And then there's dark energy, the mysterious force that's accelerating the expansion of the universe. Well, vacuum energy is a leading candidate to explain that too. But this leads to a gigantic puzzle called the vacuum catastrophe. You see, when physicists calculate what the theoretical value of this vacuum energy should be, the number they get is astronomically, staggeringly larger than what our observations of the cosmos actually show. It's one of the worst predictions in the history of physics. And this mismatch isn't just a small error. It is one of the biggest, most glaring unsolved problems in all of modern physics. This enormous discrepancy tells us there is something deep and fundamental about reality itself that we are completely missing.
So, in the end, zero-point energy forces us to completely reevaluate what we even mean by empty. And it leaves us with this powerful final thought. What we call emptiness isn't nothing at all. It's actually the most fundamental energy state of reality itself. Space isn't a void. It's the restless, energetic foundation of everything.